Okay, so let's take a look at problems 5 through 9. Here we go, problems 5 through 9. So I think this time what I'd like to do is use cotangent squared plus 1 as cosecant squared, because that would be a pretty straightforward one since I'm asking for a cosecant. Now, this is not the only way, so if you did it differently, that's all right. So keep in mind, if I told you that the tangent is -5/9, that makes the cotangent -9/5. So let's see, I got 81 over 25 plus 25 over 25 makes, I think it's is that 106 over 25 would be the cosecant squared, which is going to make the cosecant itself plus or minus the square root of 106 over 5. And it's a pretty straightforward little problem. Now, jumping into the last three problems, these are ones that I would really say you want to focus on because these are places where people have tended to have trouble every year. So there's some of these that are a little more straightforward than others. Like number 8 to me is a little more straightforward because there's really one and only one identity that's going to work for this one. But cosine is a little bit of a tricky one because there are three distinct identities that we'll actually use for a cosine of 2 theta. But since this is a sine of theta, the identity that I want, since it's compared to a sine, would be the only one right here that only refers to a sine. So I'd like to think of it as 1 minus 2 sine squared. Now, anytime you have a problem with squares, it's a really good idea to set it equal to 0. So that's what I chose to do, is bring all of those things to that other side. And then depending on how you like to do it, I don't personally always use the U substitution that I talked to you guys about in class. I just know that 2 sine times sine would be 2 sine squared. And of course, the only way to get a 1 is a couple of 1s. And then the only way that I can finish that up is somebody has to be negative and somebody's positive. So if this product is 2 sines and this is 1 sine, I would need this to be a negative and a positive in order to make that true. And so we're going to finish it up. So I know that the only way this product can be 0 is if either this piece is 0 or this piece over here is 0. And you want to remember that the sine is going to be a half at pi over 6, but that's also true at 5 pi over 6, because remember the sine is not only positive in quadrant 1, but also in quadrant 2. And the sine will be -1 straight down at 3 pi over 2. Now, not wanting to make the video too long, but one thing that we did talk about is that you can check your answers pretty nicely by just seeing what happens if you graph them. So I had the cosine of 2x and I had the sine of x, and I wanted to see when they cross. So again, this says let's only find the answers from 0 to 2 pi. Both of these waves are going to go up and down between 1 and -1. So I'm just going to give it a little bit above and below so I can make sure I see everything okay. But I have three answers according to this. And let's see, I have 1, 2, 3 places they cross. And I could validate that by hitting my trace button and asking my calculator about pi over 6. And notice that hit perfectly. And then I could ask again about 5 pi over 6, and it hits perfectly again. And I could ask about 3 pi over 2, and what do you know? That's going to be this guy right here. Notice that it jumps right to that number. So it looks like my three solutions were appropriate. Now, for number 7, there's really only one way that I know that I could go with that thing, because this is in a sine. I would like this to be a sine as well, but I know cosine squared is 1 minus sine squared. And so I have what's going to turn into a fairly similar story to the previous problem. I'm going to move things around. You're fine. Come on up. So I'm going to move things around a little bit, and I got 2 sine squareds plus a sine. And then if I bring the 2 across, it's going to be -1. And you know what? It's exactly the same question as we got over here. Now, it didn't look like it when I first started, but it is. So I'm not going to keep going. I'm just going to validate the fact that those two answers are, in fact, the same. And I think we are gonna stop right there. Okay, I will talk to you later. Bye-bye.